So let's talk about the incredible journey of artificial intelligence. We're going to go from its very first kind of clunky attempts to understand language all the way to the insanely powerful creative tools that are literally changing our world as we speak. Let's dive in.
You know, it feels like one day AI was just something you'd see in the movies, and then bam. The next, it's writing your emails, generating unbelievable images, and even writing computer code. So the real question is, how on earth did that happen? What was the breakthrough that suddenly unlocked all this creative power?
Okay, so the entire revolution, it really starts with this one surprisingly simple idea: language modeling. At its heart, it's all about teaching a machine to do one thing really, really well. Guess the next word. You know, if I say, the quick brown fox jumps over the lazy, your brain just fills in dog. The whole goal was to get machines to do that, but on a massive, massive scale.
All right, to really get where we are today, we've got to jump in the time machine and go way back to the beginning, this decades-long mission to teach computers how to speak our language.
So way back in the day, it was all about rules. In the 50s and 60s, programmers would sit there and painstakingly write out every single grammar rule they could think of. But here's the problem. Language is a mess. It's full of exceptions. So in the 80s, the whole approach shifted to statistics. Instead of rigid rules, models would just chew through tons of text and calculate probabilities. They learned that blue is way more likely to follow the sky is than, say, banana. Now, that was a huge leap forward for sure, but it was still just a fancy guessing game. But here's the thing. All those early models, they were missing something absolutely critical. Yeah, they could predict the next word, but they didn't actually understand the sentence. They couldn't really grasp nuance or sarcasm, or how a word at the beginning of a paragraph could affect a word at the end, and that was the brick wall AI had run into.
And then 2017 happened. A single research paper got published, and it didn't just knock a hole in that wall, it completely blew it to pieces. That was the actual title of this game-changing paper. Attention is all you need. How great is that? It sounds so simple, but the idea it introduced, this thing called the attention mechanism, well, that was the key that unlocked everything that came next.
So this paper, it rolls out this brand new model design called the transformer. Now, older models, they had to read a sentence word by word in order, which is not how we do it. The transformer could look at the entire sentence all at once. It could pay attention to every single word and figure out how each one connected to all the others, no matter how far apart they were.
So how does this attention thing actually work? Well, imagine a sentence like this. The cat, which was sitting on the very hot tin roof, chased the mouse. An older model might get totally lost in the middle part, but a transformer? It pays attention to cat and chased at the same time, instantly understanding who is doing the chasing. It weighs the importance of every word, and that right there is what gives it a real grasp of context.
Okay, so this transformer idea, it was a total game changer. So powerful and so efficient that it just opened the floodgates. Suddenly, researchers could build AI models that weren't just a little bigger, they were exponentially more powerful. And this, my friends, was the dawn of the large language model, the LLM.
And wow, this slide just perfectly shows the absolute explosion that happened next. Think of parameters as the little knobs and dials inside the AI's brain that get tuned during training. In just 5 years, we went from GPT-1's 117 million parameters to GPT-4's estimated, wait for it, 1.76 times trillion. That's not just growth, that is a whole different universe of complexity. Which, of course, leads to a pretty big question, right? If you have a machine with over 1 trillion knobs to tune, what in the world do you use to teach it? What kind of data do you feed this thing?
The answer? You basically feed it, well, the internet. A huge chunk of it, anyway. Take a look. The vast majority of the data comes from this massive web archive. Then you throw in tons of cleaned up text, huge libraries of computer code from places like GitHub, and then you top it all off with books, scientific papers, and all of Wikipedia. They are literally trained on a huge portion of everything humanity has ever written down and put online.
So let's recap. You take this amazing transformer architecture, you scale it up with trillions of these little knobs, and you train it on basically all of human knowledge. What do you get at the end of all that? Well, you get something totally new, generative AI.
And this is the absolute key difference. The AI we had before was mostly about analyzing things. It could tell you if a picture was a cat or a dog. But generative AI, it creates. It doesn't just spot patterns. It uses what it's learned about those patterns to make something completely new, something that didn't exist before, whether that's an email, a song, a piece of code, or a stunning work of art.
And just like that, boom, we all have this incredible new toolkit at our fingertips. We've got assistants that help us bust through writer's block, tools that write code from a simple sentence, and AIs that can turn a crazy thought into a photorealistic image. These aren't just small upgrades. These are brand new superpowers for all of us.
But of course, with any technology this powerful, this revolutionary, it's a double-edged sword. It's not all sunshine and roses. There are some serious challenges we have to face.
I mean, look, on one side, the potential is just mind-blowing. Think about personalized education for every single student, or AI assistants helping scientists cure diseases. But on the other side, you've got some big problems. These models can hallucinate. They'll just confidently make stuff up that's totally wrong. Since they're trained on the internet, they soak up all the biases and toxicity that's out there. And maybe the scariest part, they're so complicated we often have no idea why they give the answers they do. It's what people call the black box problem.
And yeah, let's talk about the cost. This number, that's the estimated cost to train just one of these top-tier models, Google's Gemini Ultra. The amount of computer power and money you need is just staggering, which means only a handful of giant companies can even afford to play in this league.
So when you step back and look at the whole thing, it's just a wild ride, isn't it? We've gone from these simple little programs that could barely string 2 words together to generative models that are literally changing how we work, create, and think. And all of this leaves us with the billion-dollar question, doesn't it? Right now, these tools are amazing co-pilots, making us smarter and more creative. But as they keep getting more and more powerful at this incredible speed, you have to wonder what's next. Are we just building a better tool, or are we taking the first steps toward creating an intelligence that could one day surpass our own? That's the question we're all going to have to answer together. Thanks for watching.